In section 9.3 of our statistics OER course, we will conduct hypothesis testing comparing two independent population proportions. In the introductory statistics textbook by OpenStax, this is section 10.3, and in the Lumen book Introduction to Statistics Corequisite, we are still in module 10 for hypothesis testing with two samples. When conducting a test to compare two independent population proportions, the following must be true. The two samples must be simple random samples that are independent. Second, the number of successes n times p and the number of failures n times q in each sample should be a number greater than or equal to 5. And 3, the population must be at least 20 times larger than the sample for each of the samples. Alternatively, this can be written as the little n, which is the sample size, less than or equal to 1/20 of the uppercase n, which is the size of the population. This keeps each population from being oversampled, causing incorrect results. The difference of the two proportions is the random variable of interest. It follows an approximately normal distribution. Generally, the null hypothesis will state that the two proportions are the same, and as a single variable value, that will be that the difference of the proportions P1 minus P2 is equal to 0. And the standard error for this distribution of the difference of the two proportions in the sample equals the square root of P1 hat times Q1 hat divided by N1 plus P2 hat times Q2 hat divided by N2, with Q being the probability or the proportion of the complement of the actual success in the binomial experiment of having a yes or no answer. Now, there is another approach to this distribution, and that uses a standard error that multiplies P times Q for what we call the pooled proportion, P bar or PC combined. And this pooled proportion, P bar or PC, equals the proportion of successes in total out of the total size sample between the two samples. So if I have x1 success in sample 1 of size n1 and x2 successes in sample 2 of size n2, then the pooled proportion is x1 plus x2 divided by n1 plus n2. And there is another method of creating the distribution of the difference between the two proportions where the standard error here is calculated only from the pooled proportion for each of the contributing standard deviations. So depending on what application you use or what technology you use, you can have the choice to pool the proportion or to not pool the proportion, and you need to know which one of the two it applies to. So the random variable has a mean of P1 minus P2 and a standard error of a similar calculation depending on how the proportions are determined. And the test statistic is a z-score that equals the difference between the sample proportions minus the mean of this distribution divided by the standard error of the distribution. So let's try an example. We will use Art of Stat to find the answers, and then we will investigate in Excel to see what does Art of Stat do and how it calculates the values. So we have two types of medication for hives, They are being tested to determine if there is a difference in the proportions of adult patient reactions. And we have a sample of 200 adults, and they were given medication A, and 20 out of that random sample had hives 30 minutes after taking the medication. Then we had another sample also of 200 adults, different adults. They were given medication B, and 12 of those out of the 200 still had hives after 30 minutes. And we want to test at the 1% significance level. And let's do some preliminary calculations and then compare our math with what ArtofStat will give us. So the P1 hat or PA hat for the sample that was given medication A will be 20 out of 200. That is 0.1. And the P2 hat or PB hat is for the sample that was given medication B, equals 12 out of 200 or 0.06. We will have a null hypothesis, that is that the two proportions A and B for the population are equal to each other, or that the variable of the difference is equal to 0. And the alternative hypothesis, since the question is to determine if there is a difference and not a preference of the one medication over the other medication, then our alternative hypothesis will be that these two proportions are different from each other, or that the difference of them is not equal to 0. And we calculated ourselves PA hat and PB hat, so we can actually calculate the difference here. 0.1 minus 0.06, this is 0.04. And we can also calculate the pooled proportion, that is x1 plus x2, 20 plus 16, where the adults in each sample that had hives 30 minutes after taking the medication in the bottom, and 1 plus n2, 200 plus 200. And 36 divided by 400 is 0.08. Sorry, it's not 16, it's 12. So 32 divided by 400 is 0.08. Anyways, let's use ArtofStat, and let's use some technology to quickly conduct this hypothesis test. I'm going to go in the web apps, and I'm going to compare two proportions. I'm going to use this app under the block of confidence intervals and tests, comparing two groups. So I'm going to click on compare two proportions, and I will enter data with the number of successes. I'm going to leave them as group 1 and group 2. 1 will be the medication A and 2 will be the medication B. I can also call it group A and group B, so I can edit these names. The sample size for group A is 200. The number of successes on the right of it is 20. In group B, the sample size was 200 and the number of successes was 12. I need a hypothesis test, so I'm going to select the type of inference to be a significance test. I have the option to do two-sided, left tail or right tail. I do want a two-tail test. The null value for the difference is equal to 0. The difference of proportions is equal to 0. And I want to see the pooled proportion, so I'm going to select that. And let's also see the test decision. Actually, let's wait and discuss it first, then see if it will pop up. So if you notice here, it creates this table, sample size of 200, successes 20, divides those two to get a sample proportion of PA hat of 0.1, and group B 200 with success is 12 and a sample proportion of 0.06. The null value for the difference is 0. The observed difference 0.04, which we already had determined. The pooled proportion 0.08, which we also determined ourselves. The null standard error, that is the standard deviation of this distribution, 0.0271. So I'm going to write it here, that the distribution of PA hat minus PB hat follows a normal distribution with a theoretical mean of 0, which is the difference, the theoretical difference of the two proportions, and the standard deviation of 0.271. And this one we will highlight to investigate later in Excel. We want to know what type of standard error does ArtofStat use. Does it use this quantity that takes into account P1 hat and P2 hat? Or does it use this formula that only takes into account the pooled proportion? So we will investigate that later, but for now let's continue our hypothesis test here in ArtofStat. It says that the null standard error ended up being 0.0271. We will that was the standard deviation, remember, that we will investigate later. The test statistic is a z-score 1.474. You find this by taking your observed difference, subtracting it from the mean difference, and dividing it by the standard error. The answer was 1.474. So z equals 1.474. If you pay attention here, this is a standard normal distribution. So standard normal distribution means that every tick mark is one standard deviation and not equal to the standard error here. So every tick mark is not equal to 0.0271. So if we want to just copy this particular graph, we don't want the label of our axis to say this is the difference of the two proportions, the two sample proportions. We want to say that this is the z-scores of the difference of the two proportions, so that every one of the tick marks here will be a 1, and to the left also a 1, and what we will be placing on the axis is the test statistic z-score. And 1.474 is approximately 1.5. Because this is a two-sided test, a two-tail test, we also need the symmetric to the left of the mean, and we are looking for the p-value to be the area under the curve in both tails. So the p-value is calculated in ArtofStat to be 0.1404. So your p-value is 0.1404. This is a probability equal to the area under the curve, different from the standardized score of the difference of the two proportions that came out to be 0.04, and then when standardized came out to be 1.474. Remember, z-score is the number of standard deviations that you are away from your mean. So the 1.474 is how many standard deviations away from 0 we will be, and the 0.14 is the probability or area under the curve in both tails. So each one of these tails will actually get half of the probability. So half of 0.1404, if you pay attention here in the graph, is 0.0702 on the left and 0.0702 on the right. When you add them together, you get 0.1404, which is double each one of those areas. So this is 0.0702, and this is another 0.0702 that total up to 14.04%. The p-value happens to be greater than alpha. That means that the difference of sample proportions equal to 0.04 is actually not an unusual outcome coming from a theoretical distribution that sets the difference of the two population proportions equal to 0. And therefore, the decision is that we fail to reject the null hypothesis. Now, the conclusion will be that at the 1% significance level, the sample evidence did not provide sufficient evidence to reject the null hypothesis. Remember, in your conclusion, you cannot mention the null hypothesis. You want to also say, we didn't have enough evidence to support the alternative. And your alternative hypothesis is that there is a difference in the proportions of adult patients' reactions taking the two medications. So you can pause the video and write your conclusion, then compare your conclusion to the conclusion that you will see written after you restart the video. Now let's see if the ArtofStat app can do for us the test of the decision. The significance level is 1%, and here it says, at the significance level alpha equals 1%, we fail to reject the null hypothesis because the p-value is 0.1404 is greater than 0.01. There is insufficient evidence that the two population proportions differ. Remember, this is your alternative hypothesis. And one thing that it mentions here is that you can check the confidence interval to see plausible values for the difference between the two population proportions. In our course, this will be a separate task, but in a regular statistics investigation, you will want to use the confidence interval to find possible differences between the two populations. Now, one thing that we want to do here is to go in Excel and find out how this null standard error was calculated. So I have here the table where I have entered the X and the N for every one of the samples. This is group A, that will be population 1, and this is group B, that will be population 2. And I'm trying to imitate it here with ArtofStat. So I need to find the sample proportions, PA hat and PB hat. And the way to do that is to divide X by N for each one of the samples. I don't want to use numbers. I could have used my calculator if I wanted to use numbers. I want to be able to change the values, like someone will change the values here in the inputs for ArtofStat and find the answers all the time without recalculating. I'm going to do the same thing in the second one. I'm going to divide the X and the N to find the two P hats, and the observed difference will be the population, the proportion from the first sample, P1 hat, minus the proportion of the second sample. To find the pooled proportion, if you remember, we will add the X values from the one sample and the other sample, and we will divide by the sum of the sample sizes. So n1 plus n2, and again, I don't want to put in the numbers. I did the math in my calculator or in my head earlier on paper. I want here things to vary. So the question here now is, what is the standard deviation of the null? So what ArtofStat here calls the null standard error. And we have two options. The one option is to use the P1 hat and the P2 hat, and the other option is to use the pooled proportion. So let's see which one ArtofStat uses. So I'm going to find them both. So square root of, and I'm going to do P1 hat times 1 minus P1 hat, that will be the Q1 hat, divided by N1, plus P2 hat times 1 minus P2 hat, that will be Q2 hat, divided by N2. And that is one of them. And that comes out to be 0.2706. And then I'm going to do it with the pooled proportion, so equals square root of, and I'm going to do pooled proportion times 1 minus the pooled proportion, that will be the Q that is pooled, divided by N1, plus pooled proportion times 1 minus the pooled proportion, divided by N2. And I see that the answer here is 0.02713. So actually, to accuracy at 4 decimal digits, I don't know which one of the two is used in ArtofStat. So to continue here, I'm going to try to find the test statistic Z, which is well, actually, I guess I will have to find the p-value, and that will tell me the answer. The test statistic, let's find out. It is the observed difference minus the null difference divided by the standard error. So let's find out if that will solve the problem. So here, the test statistic will be the observed difference, 0.04, minus the null difference. We don't have a location here where somebody gave us the null difference. If you remember, when we asked for a significant test, we did select these boxes that said we want the null value for the difference. It automatically comes up to be a 0. So here we didn't have an input provided, so we will just enter that mean manually, and we will divide by this standard error to see what the z-score will be. And here, this test statistic, we will do the same thing. We will say the observed difference minus the null difference, which is assumed to be 0, divided by this null standard deviation. So let's see if now we can determine which one of the two is the one that is used in ArtofStat. So ArtofStat said that the test statistic is 1.474. So if you pay attention here, actually ArtofStat is using this value, which means that they are using the standard error calculated with the pooled proportion. So in ArtofStat, the standard error and test statistic are calculated with the pooled proportion. So now you know which ones to select. Therefore, your test statistic from here will have to equal, if you want to follow the ArtofStat test, will equal to this location, the test statistic calculated with the pooled proportion, and then the p-value will be the probability in both tails. So how are we going to find the probability? We will use the standard normal function in Excel, which assumes a mean of 0 and a standard deviation of 1. But when we give it this z-score that is positive, the CDF will calculate the area under the curve to the left of this value, and the area under the curve to the left of this value will not equal to the area of the tail on the right. So to find the area of the tail on the right, we will take the CDF coming from Excel that is giving us the area to the left and subtract it from 1. That will give us the area in one tail, and due to symmetry, then we will just double it to find the area altogether, because both tails will add together to give us the p-value of 0.1404. So the p-value will equal to 1 minus, and I want the normal distribution dot S, which is the standard normal distribution. It will return the standard normal distribution with a mean of 0 and standard deviation of 1. So I want this. It tells me what is the z-value. It is equal to this test statistic, comma. Do you want it to be a cumulative? The answer is yes, I do. So true. This will calculate the area in one tail. So let me check. Yes, it does come out to be 0.0702. And to find the correct p-value, because this is a two-tail test, I'm going to take this and multiply it by 2, and it will give me the p-value of 0.14037. So I did find now the answers that Art of Stat gave me really quickly without me having to do all of that math. And now I know that Art of Stat actually pulls the proportion. Now, if it didn't pull the proportion, so if this was not checked, let's see if the values change. It does not change. So the Art of Stat app always pulls the proportion. If you have this checked, it will just show you what the pull proportion is so that you know how to do the math by hand if you want.